ಈಡ ಬ್ಯಾಗ್ ಅದ್ರ ಮ್ಯಾಗ ಇಡ ಅಲ್ಲಿ ಅರ್ಬಿ ಇರ್ಲಿ.
Yes, good evening, students. So let us start with the today's class, electric field and charge. So the last part of the questions we are discussing. Yes, you will be able to see the screen. So let us discuss some of the questions. Okay, so see here, that is yes, see, in the last class, we discussed about this question. The SI unit of electric flux we have completed. Then after that, we have completed this question also. So charge calculate ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳಿದ್ರು. By using the torque formula, we have calculated the charge. So see the today's question, students. Hope so last class ಅಲ್ಲಿ ಇದ್ರಿ ನೀವೆಲ್ಲರೂ ಅಂತ assume ಮಾಡ್ತೀನಿ. I'll continue with the questions. Okay, see the question. A uniformly charged conducting sphere of 4.4 meter diameter has a surface charge density of 60 microcoulomb per meter square. The charge on the sphere is. So what is the charge on the sphere? They are asking again. So here you have a conducting charged sphere of 4.4 diameter has a surface charge density of 60 microcoulomb per meter square. So charge density, surface charge density anta andre sigma value kottidare. Okay. So the sigma value is given here. The sigma value is given. The sigma value is how much it is. So if you see the sigma value, it is 60. So sigma value is given as 60 micro coulomb per meter square. Okay. So and its diameter is given. Diameter is 4.4 meter. They are asking you to calculate the charge. So in this case, what you are going to do, as we know that is, so if anybody knows, you can do with the calculation part. Surface charge density is equal to charge per unit area anta ಹೇಳ್ತೀವಿ. So that is surface charge density is what? Charge per unit area. Here we are using ಯಾವ ತರ shape ಅನ್ನು use ಮಾಡ್ತಾ ಇದೀವಿ? We are using that is sphere. So sphere area ಏನಾಗುತ್ತೆ? Can anyone tell me what is the area of the sphere?
4 pi r square.
4 pi r square. Yes, very good. So 4 pi r square is the area. You can substitute 4 pi r square. Radius is not given, but diameter is there. So diameter ಇರೋದ್ರಿಂದ radius ಅನ್ನ half ಮಾಡಿ ತಗೊಳ್ಬೋದು. We require charge. Therefore, it is sigma into A. A value is 4 pi r square. So 60 into 10 raised to minus 6 into that is 4 into 22 by 7 or 3.142, anyhow you can take, into radius, that is diameter is 4.4. So you can just make it as 4.4 divided by 200, 2.2 agatte. So directly I can take it as 2.2 its whole square, which is equal to your Q. So just check what answer you are going to get, students. A, B, C, D. So 2.2 square ಇದೆ. So some students will not do that square. So square ಮಾಡಲಿಲ್ಲ ಅಂದ್ರೆ answer wrong ಬರುತ್ತೆ. So do it properly. Keep yourself mute. Yes. This we have completed. No, this one also completed. I thought only previous is completed. Option D is the answer. That is 3.7 into 10 raised to minus 3. Okay, maybe I don't remember. Maybe this was the last question which we discussed in the last class. Okay, option D ಬರುತ್ತೆ ನೋಡಿ. ಯಾರು ಇರ್ಲಿಲ್ಲ ಅಥವಾ ಯಾರು ಕಾಪಿ ಮಾಡಿಲ್ಲ, you can copy that. So option D is the answer. Going for the next question, students. Let's see the next question. Yes, so we have the theory question. You can answer that. Read the question and tell me what is the answer. Yes, a sphere encloses an electric dipole within it. A sphere encloses a dipole within it. The total flux across the sphere is. So what will be the total flux within the sphere? Zero, half that due to a single charge, double that due to a single charge, dependent on the position of the dipole. Yes, what is the answer? See. Yes, very good. Kajal, Srivaruni. Yes, other students. See, option A is the correct answer here, students. That is that charge enclosed by the sphere, the total flux across the sphere is zero. Yak heli? Because inside the sphere we don't have any charge. Hauda? So charge illa anta andre here what happens, the electric field will be zero. Electric field zero irodrinda flux kuda zero agatte. Hope so the reason is clear to everyone. Answer is option A, zero is the answer. Aita, so go for the next question. A point charge 4 microcoulomb is at the center of cubic Gaussian surface 10 centimeter on edge. Net electric flux through the surface is. What is the net electric flux through the surface? So electric flux they are asking you to calculate. Charge value is given. Gaussian surface, its side value is also given. So see how you are going to do. We need to calculate the net electric flux. So see, we know that according to Gauss theorem, navenanta use madbodu. According to Gauss theorem, we can write it as the total flux is equal to charge upon epsilon naught. Because how we define that flux is nothing but that is 1 upon epsilon naught times the total charge enclosed by the surface. So therefore it is Q upon epsilon naught. The value of Q is given in the question 4 microcoulomb. Therefore 4 into 10 raised to minus 6. The epsilon naught value we know 8.85 into 10 to the power of minus 12. So simplify, you will get the answer. No need to go for that edge surface value. Yes, Shivaruni. Yes, Kajal, correct answer. Other students, option B, Baratte Nodi. So simplification part, please you only carry on. Illi power Baratte Nimge. You will get it as 10 to the power of 5. 10 to the power of 5 will be there. And if you simplify this part, it is 4.5 to 10 to the power of 5. Yes, everyone, option B. Moving towards the next question. Okay. Yes, a rod of length 2.4 meter and radius 4.6 millimeter carries a negative charge of 4.2 into 10 to the power of minus 7 coulomb. So you can see what all it is given. Charge value is given. See which shape they are specifying. Okay, that is length is given as 2.4 meter, radius is also given. Spread uniformly over its surface, the electric field near the midpoint of the rod at a point on its axis is. So you need to calculate the distance. Yes, how you are going to see. Here the length is given as 2.4 meter. The radius is given by 4.6 millimeters. So radius is given as 4.6 millimeter. Convert it into meters. It will become 10 raised to minus 3 meters. The value of Q is also given 4.2 into 10 raised to minus 7 coulomb. Yes, three quantities they have given. See what we are going to do next. Okay. So here we need to calculate the electric field near the point. Sorry, electric field kedidare distance alla. They are asking you to calculate the electric field. So to calculate electric field, what all formulas we have? It is a linear rod anta ಹೇಳ್ತಾ ಇದ್ದಾರೆ. So Gauss law application ನಾವು study ಮಾಡಿದೀವಿ students. So Gauss law application ಅಲ್ಲಿ the first derivation see. The Gauss law applied for the, that is infinitely long straight wire. You can use that formula to calculate the electric field. So the electric field is equal to 1 upon 4 pi epsilon naught. Okay, then it is lambda upon r. Okay, but here one twist is there in the question. See, a rod of length. So question salpa describe madana. You have a rod of length 2.4 meter. Its radius is given. Carries a negative charge of 4.2 into 10 raised to minus 7 coulomb spread uniformly over the surface. The electric field near the midpoint of the rod. So near the midpoint kelta idare students illi. So near the midpoint kelirodrinda, here we have the formula. So this is a star formula. You have to remember this for this type of numericals. So theoryal kaliyalla navi formula na, but here we are using that. That is 2k into lambda by r into sine of alpha divided by 2. Wait a minute, they have not given one value in this. One value is missing in the question actually. Now I don't have that book. Okay. So in this question, option C, yes, C, we will get it. Only Q by L. But lambda they are asking, no. Okay, lambda is equal to E value they are asking. So E, this is Q by L. Okay, just we will give a try, students. Nodana ee tara baratta anta. So lambda is equal to Q by L. Negative charge helidare, therefore it is 4.2 into 10 to the power of minus 7 divided by length is 2.4. Just we will check it, okay. Whether in the given option we are getting answer or no. Yes, so if we do this one, we are getting here illenagatte Q by L maddaga we will get it as minus 1.75 into 10 to the power of minus 7 coulomb per meter. Yes, so electric field is equal to what you are doing, lambda upon 2 pi epsilon naught into r. Okay, check. If you are getting the correct answer, then no problem. Yes, for lambda, what we have, that is lambda, that is electric field intensity is equal to, yes, infinitely long straight wire, lambda upon 2 pi epsilon naught into r. Yes, everyone check. You should get option C. You have all the other values. Substitute ಮಾಡಿ, check ಮಾಡಿ. So here we have the electric field is equal to, the lambda value is minus 1.75 into 10 to the power of minus 7 divided by, so instead of 2 pi epsilon naught in madkoli, in the numerator multiplied by 2. ಡಿನಾಮಿನೇಟರ್ ಏನಾಗತ್ತೆ, ಮಲ್ಟಿಪ್ಲೈ ಅಂಡ್ ಡಿವೈಡ್ ಬೈ 2 ಮಾಡಿದಾಗ ಇದು 4 pi epsilon naught ಆಗತ್ತೆ into r. So which is equal to minus 1.75 into 10 to the power of minus 7 into 2 divided by 1 upon 4 pi epsilon naught value is 9 into 10 raised to 9, and the r value is given in the question. Just check whether you are getting C or no. Otherwise, something is missing in the question. Yes, everyone. See, Bharatta nodi. All the values I have substituted. Yari yav step artha aglilla, please keli.
minus 6.8 ಬರುತ್ತೆ.
Minus 6.8. Okay, no problem. 10 to the power, yes. 10 to the power of plus 5. 6.8 or 6.7. So whatever it is, the power will be 10 to the power of 5 Birbeck nodi students. 6.8 or 6.7. So minus 6.7 into 10 to the power of 5 Newton per Coulomb. Yes, everyone, any step ಯಾರಿಗೆ ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ಕೇಳ್ಬೋದು. Yes. ಹೋಗೋಣ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ನೋಡೋಣ ಸ್ಟೂಡೆಂಟ್ಸ್. Okay. Yes, see the next question. A certain charge Q is divided into two parts, Q and Q minus Q. For the maximum Coulomb force between them, find the ratio of Q by Q. So question is little interesting. ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ ನೋಡಿ, ಕ್ವಶನ್ ಅನ್ನು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ ಇಲ್ಲಿ ಸ್ಟೂಡೆಂಟ್ಸ್. So what they are saying here, the charge Q is divided into two charge. So ಅದನ್ನ ಎರಡು ಚಾರ್ಜ್ ಆಗಿ ಡಿವೈಡ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ. It is becoming Q and Q minus Q. So for the maximum Coulomb force between them, the ratio of Q by Q they are asking. So we need to calculate the ratio of Q divided by Q. So let us see how to do this one. You can also just give a try. So we have, according to Coulomb law, so according to Coulomb force, we can substitute F is equal to 1 upon 4 pi epsilon naught Q1 into Q2 divided by R square. So charge ಏನಾಗ್ತಾ ಇದೆ, Q1 is Q and Q2 value is Q by Q minus Q upon R square. Okay, so maths ಅಲ್ಲಿ I think differentiation may be maxima minima ಅಂತ ಹೇಳಿ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಕಲಿತೀರಾ, ನೀವು ಕಲ್ತಿದ್ದೀರಾ ಇಲ್ಲ I don't know, but ಅಲ್ಲೊಂದು ಕಂಡೀಷನ್ ಬರುತ್ತೆ. So for the maxima, that is df by dq, ಅಂದ್ರೆ ಇದ್ರದ್ದು ಏನ್ differentiation ಇದೆ, the differentiation value will be 0. Okay, so for the maxima, the condition in maths we'll study maxima minima anta. Yes, so here for the maxima, the differentiation of df with respect to q value will be 0. Okay, ಅಲ್ಲಿ ಯಾವ ಫಂಕ್ಷನ್ ಇರುತ್ತೆ ಅದರದ್ದು differentiation 0 ಅಂತ ಆಗತ್ತೆ for the maxima. ಆಯ್ತಾ? So now we are going to substitute that. So this equation 1 ಅಂದ್ರೆ ಇದೇನ್ ಫಾರ್ಮುಲಾ ಇದೆ, this formula we have to differentiate this formula. See, so ಈ ಫಾರ್ಮುಲಾನ ನಾವೀಗ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡೋಣ. If we differentiate this formula, here 1 upon 4 pi epsilon naught is constant. So 1 upon 4 pi epsilon naught constant ಇದೆ, keep it as it is. Then next, I don't know you have studied differentiation or no. So ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ಈಗ just copy ಮಾಡ್ಕೊಳ್ಳಿ. Later you can understand that, because here I cannot explain you mathematical steps because it will take too much time. Okay, so here constant ಏನಿರುತ್ತೆ, differentiation ಮಾಡ್ಬೇಕಾದ್ರೆ constant terms ಅನ್ನ ಹೊರಗಡೆ ಇಟ್ಟು remaining terms ಅನ್ನ ನಾವು differentiate ಮಾಡ್ತೀವಿ. Yes, so ಇಲ್ಲಿ product rule apply ಮಾಡ್ತಾ ಇದ್ದೀವಿ for q into q minus q. So here what term we have, that is q into q minus q. ಈ ಟರ್ಮ್ ಅನ್ನ ನಾವು ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ. ಓಕೆ, So first keep the first term as it is, differentiate the second term, keep the second term as it is, differentiate the first term ಅಷ್ಟೇ. Okay, so for example ನಿಮ್ಗೆ ಅದನ್ನ ಸಪರೇಟ್ ಆಗಿ ಇಲ್ಲಿ ಹೇಳ್ಬೇಕು ಅಂದ್ರೆ uv ಅಂತ ಒಂದು ಟರ್ಮ್ ಇದೆ ಅಥವಾ xy ಅಂತ ತಗೊಳ್ಳಿ. when you are differentiating this one with respect to y, ಅವಾಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ first term as it is, the differentiation of second term plus second term as it is, the differentiation of the first term. ಆಯ್ತಾ? ಸೊ ಇಲ್ಲಿ dy by dy ವ್ಯಾಲ್ಯೂ ವಿಲ್ ಬಿ 1 ಆಗತ್ತೆ. ಸೊ therefore x plus y dx into dy ಈ ತರ ಬರಿತೀವಿ. ಸೊ ಇಲ್ಲಿ ನಮ್ಮ ಹತ್ರ ಇರೋದು ಕ್ವಶನ್ ಏನಿದೆ, ನಾವು ಅದನ್ನ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಸ್ಮಾಲ್ ಕ್ಯೂ ಮಾಡ್ತಾ ಇದೀವಿ. ಟರ್ಮ್ ಏನಿದೆ q ಇಂಟು q ಮೈನಸ್ q ಅಂತ ನಮ್ಮ ಹತ್ರ ಟರ್ಮ್ ಇದೆ. ಓಕೆ, ಸೊ ಯು ಕ್ಯಾನ್ ಸಿ ಅದ್ರ ಪ್ರಕಾರ. ಸೊ ಇಲ್ಲಿ ಸ್ವಲ್ಪ ಸೆಕೆಂಡ್ ಟರ್ಮ್ ಅದೇ ರೀತಿಯಾಗಿಟ್ಟು ಫಸ್ಟ್ ಟರ್ಮ್ ಡಿ ಕ್ಯೂ ಅನ್ನ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದಾಗ 1 ಬರುತ್ತೆ, ಪ್ಲಸ್ ಕ್ಯೂ ಅನ್ನ ಅದೇ ರೀತಿಯಾಗಿಟ್ಟು ಕ್ಯೂ ಮೈನಸ್ ಕ್ಯೂ ಅನ್ನ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದಾಗ -1 ಉಳಿಯುತ್ತೆ. ಸೊ ವಿ ಹ್ಯಾವ್ ಡಿಫ್ರೆನ್ಶಿಯೇಟೆಡ್ ದಿಸ್ ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 0. ನಾವ್ ಇದೇನೇನ್ ಇಲ್ಲಿ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ನಲ್ಲಿ ಟರ್ಮ್ ಇದೆ ಸ್ಟೂಡೆಂಟ್ಸ್, ದಟ್ ಇಸ್ 1/4πε0 1/r² ಅನ್ನ ಈ ಕಡೆ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡಿದ್ರೆ 0 into this value will be 0. So 0 into this value will be 0. What is remaining? Q minus Q is equal to 0. ಹಾಗಾದ್ರೆ ಬರೋದೇನು, that is Q minus 2Q ಅಂತ ಬರುತ್ತೆ. We will get it as Q minus 2Q which is equal to 0. So question ಅಲ್ಲಿ ನೋಡ್ಬೋದು ಅವರು ರೇಷೋ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. In the question they are asking the ratio. So they are asking Q by Q. So Q by Q ಅಂತ ಹೇಳಿದಾಗ what we can do here is keep Q here, this one transfer, minus ಇದ್ದದ್ದು ಪ್ಲಸ್ ಆಗತ್ತೆ. ಆಯ್ತಾ? ನಮಗ್ ಬೇಕಾಗಿರೋದು ಸ್ಮಾಲ್ q by capital Q. Therefore Q by Q is equal to, it is 1 divided by 2. Option A is the correct answer. C. Yes, so differentiation ನಿಮಗೆ ಗೊತ್ತಿಲ್ಲ ಅನ್ನೋದಕ್ಕೆ ಸ್ವಲ್ಪ ಟಫ್ ಆಗ್ಬೋದು. But if you know that part, it will be easy. Yes, option A is the answer. 1/2. ಏನಿಲ್ಲ ಅಲ್ಲಿ ಬರೀ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಮಾತ್ರ ಮಾಡ್ತೀರಾ, ಬಿಕಾಸ್ ಮ್ಯಾಕ್ಸಿಮ ಅಂದಾಗ df by dq will be 0. So therefore we are differentiating that. That's it. Okay, you people know differentiation, then it is very good. Yes. So who attended the classes here in the April, May? What classes we have conducted in that ನಿಮ್ಗೆ ಗೊತ್ತಾಗಿರುತ್ತೆ. ಬಿಕಾಸ್ ಕಾಲೇಜಲ್ಲಿ ಐ ಡೋಂಟ್ ಥಿಂಕ್ಸ್ ಸೆಕೆಂಡ್ ಇಯರ್ ಅಲ್ಲಿ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಇಷ್ಟು ಬೇಗ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾರೆ ಅಂತ. ಸೊ ಇಟ್ ಡಿಪೆಂಡ್ಸ್. Okay, then go for 22 questions, students. Yes, option A 1/2 is the answer. Go for question number 22. When air is replaced by a dielectric medium of constant K, the maximum force of attraction between two charges separated by a distance. So ಏನಂತ ಇದೆ ಇಲ್ಲಿ ಕ್ವಶನ್ ಅಲ್ಲಿ, when air is replaced by a dielectric medium of constant K, the maximum force of attraction between the two charges. So you have two charges here. ಇದು ಎರಡರ ಮಧ್ಯೆ ಏರ್ ಇಲ್ಲ. ಏರ್ ಈಸ್ ರಿಪ್ಲೇಸ್ಡ್ ಬೈ ಸಮ್ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಮೀಡಿಯಂ. ಸೊ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಮೀಡಿಯಂ ಅಂದ್ರೆ ಮೈಕಾ ಇರ್ಬೋದು ಅಥವಾ ಯಾವುದೇ ಒಂದು ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ಅನ್ನ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡಿದಾಗ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಟು ದ ಫೋರ್ಸ್ ಬಿಟ್ವೀನ್ ದೆಮ್? ದಟ್ ಇಸ್ ದ ಕ್ವಶನ್. See? Yes, other students. Okay, just a minute. Yes, option C is the correct answer. That is, it decreases by K. Okay. So going for the next question, students. See the question. A particle of mass m, charge q is placed at rest in a uniform electric field E and then released. The kinetic energy attained by the particle after moving a distance y is. Yes. See what they are asking and what they have given here. They are asking you to calculate the distance. Okay. So distance calculate ಮಾಡ್ಲಿಕ್ಕೆ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. What all it is given in the question, you can check. That is, mass is there, charge is there, electric field E anta helidare, energy E. So let us see how to do this one. See, we know that the three equation of motion, in that I'll take v square is equal to u square plus 2as. So instead of s, I'll take it as y because distance y anta describe madidare question alli. Okay, so here you can see the first line. It is placed at rest. So when they are saying it is at rest, the u value will be 0. Hagadre enagatte, v square is equal to 2ay anta agatte, which is equal to. So here keep the 2 as it is. Force is equal to, we have F is equal to m into a, therefore a is equal to F by m. Therefore this becomes F by m into y. Okay, so therefore now we are going to substitute that. So 2 into bracket F by m into y. Next, they're asking you to calculate the kinetic energy. Hagadre kinetic energy is equal to half mv square. That is equal to. So 1 by 2 hage edi, m you keep it as it is. V square value we have already written here. 2 into F by m into y. So 2 will get cancelled, m will get cancelled. Namgul iddirodu F into y. But according to the electric field definition, substitute madidre, you will get the final answer. Yes. According to electric field definition, electric field is equal to force upon charge. So therefore, force is equal to electric field into charge into y. So it is nothing but QEY. Option A is the correct answer. Yes. Yes, copy down everyone.
Excuse me, ma'am.
Yes.
Ma'am, can you explain the last two steps?
Okay, last step. Okay. So here we need to calculate the kinetic energy attained by the body. So kinetic energy is equal to, we have, that is half mv square. So this 1 by 2, I am keeping it as it is. Mass also I am keeping it as it is. The velocity value, the final velocity, we got it as v square is equal to, that is 2 into F by m into y. So that directly we are taking v square, because here v square we have, here also v square is there. Therefore it is 2 into F by m into y. So here 2 will get cancelled, mass term will get cancelled, and the remaining is F into y. y is the distance. So according to electric field definition, electric field is equal to force per unit charge. Therefore, force is equal to electric field into charge. So therefore, F I can substitute it as what? EQ into Y. So therefore, option A. Yes, anybody is having doubt again? Okay, students, going for the next question. See the next question. A dipole of dipole moment P and electric field E, then torque acting on it is given by. So it is a mathematical expression. You can tell me directly this answer. So torque with respect to dipole, what is the expression? P dot E, P cross E, P plus E, P minus E. So C, D antu barala, whether it is A or B.
B.
Yes, that is PE sin theta anta baritivi. So when we are writing sin theta, it is cross product. So that is option B is the correct answer. Go for the next question. The electric field at a distance of 3r by 2 from the center of a charged conducting spherical shell of radius r is E. The electric field at a distance of r by 2 from the center of the sphere is. So here they are giving the electric field at a distance 3r by 2 from the center of the charged sphere is E. So 3 by 2 distance, 3 by r into 2 distance iddaga, it is E. Hagadre distance, if it becomes r by 2, what will be the electric field? So try it. Even I'll show you how to do this one. So options we have 0, E by 2, 3 by, E by 3. Yes, very good. Other students? 24 is B. "24 is B. So we are discussing 25. "25 is A. Okay. So nobody answered. I don't know what ನೀವೇನ್ try ಮಾಡ್ಲಿಕ್ಕೆ ಹೋಗ್ತಾ ಇದ್ದೀರಾ ಅಂತ. See, ಯಾಕೆ 0 ಆಗತ್ತೆ ನೋಡಿ. The electric field at a distance of r by 2 from the center of the sphere is. So here 3r by 2 ಅಂತ ನೀವು ಹೇಳಿದ್ರೆ ಅದೇನಿದೆ, that is r by 2 ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? I'll explain you. See. So if you consider anyone's shape here, ಆಯ್ತಾ? So ಇದ್ರ ರೇಡಿಯಸ್ ನೀವು r ಅಂತ ಹೇಳಿದಾಗ r by 2 ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? It will become half. So inside the body, what is the electric field here, students? It is 0. Therefore, option A is the correct answer. Yes, understood?
Yes, ma'am.
Ma'am, can you explain it once again?
25th?
Yes, ma'am.
See, 25th, what is the question here? They are asking you to calculate the electric field at a distance of r by 2. Here r is the radius of that spherical shell. Okay, so r ಅನ್ನೋದೇನಿದೆ radius of the spherical shell. What is the electric field at a distance of r by 2 ಅಂದ್ರೆ radius ದ್ದು half value. So whatever it is there, it will come inside the spherical shell. Inside the spherical shell. So inside the spherical shell ಅಥವಾ inside the body, the electric field will be always 0. Why? Because the electric field intensity depends on the charge. Electric field ಅನ್ನೋದೇನಿದೆ charge ಮೇಲೆ depend ಆಗಿರುತ್ತೆ. Okay, so according to charge properties, charge only resides only on the surface of the body, not inside the body. Inside the body iralla. ಸೊ ಚಾರ್ಜ್ 0 ಆಗತ್ತೆ, therefore electric field value 0 ಆಗತ್ತೆ. ಸೊ ಕೊಟ್ಟಿರೋ ಕ್ವಶನ್ ಅಲ್ಲಿ within the sphere it will come, therefore it is option A. Yes, any doubt, students?
No, ma'am.
Okay, going for the next. See, a hollow insulated conduction sphere is given a positive charge of 10 microcoulomb. What will be the electric field at a center of the sphere if its radius is 2 meter? Is a hollow insulated conduction sphere. Yes, what is the answer? Just now I have explained one concept. See the question. Question artha madಕೊಳ್ಳಿ, how they are asking the question. Directly don't go for calculation. Yes, only Lubna answered. What about others? See, students, here clearly they are asking, ille ide nodi, what will be the electric field at the center of the sphere? Yes, Kajal, remaining students. Center irli, ಒಟ್ಟು ಅದು ಒಳಗಡೆ ಅಂತ ಬಂದ್ರೆ ಆಯ್ತು. Okay, ಏನ್ shape ಇರತ್ತೆ, it is not only for the sphere, whatever may be the shape inside the body, the electric field will be 0. Yes, Srivaruni, option C is the correct answer. Yes, everyone. So inside radius ಒಳಗಡೆ ಬಂದ್ಬಿಟ್ರೆ ಮುಗ್ದೋಯ್ತು. If it is on the surface only, you have to calculate. So on the surface ಇದ್ರೆ you have to substitute the formula and calculate the electric field. But inside ಅಂತ ಹೇಳಿದ್ಮೇಲೆ electric field 0 ಆಗತ್ತೆ. Actually next topic ನಾವೇನ್ ಹೋಗ್ತಾ ಇದೀವಿ ಅಲ್ಲಿ ನಿಮ್ಗೊಂದು ಕನ್ಫ್ಯೂಷನ್ ಸ್ಟಾರ್ಟ್ ಆಗತ್ತೆ. Because electric potential 0 ಆಗಲ್ಲ, ಬರೀ electric field ಮಾತ್ರ 0 ಆಗತ್ತೆ ಯಾವಾಗ್ಲೂ. Okay, so next topic ಅಲ್ಲಿ ನೋಡೋಣ ಅದನ್ನ. Go for the next question. A charge Q is enclosed by a Gaussian spherical surface of radius R. If the radius is doubled, then the outward electric flux will be. What happens to the electric flux? Yes. Yes, C is the correct answer. Other students? C baratte nodi students. Here the answer is C. See here, if the radius of the Gaussian surface is doubled, the outward electric flux will remain the same. ಯಾಕಂತಂದ್ರೆ electric flux depends only on the charge enclosed by the surface. So electric flux ಅನ್ನೋದೇನಿದೆ depends on the charge. It is not depending on the radius. Okay. So therefore it remains same. Option C is the correct answer. Going for the next question. Another 3 questions we have. So polar molecules are the molecules. Yes, theory question. Having permanent dipole moment, having zero dipole moment, only in presence of the electric field, only when magnetic field is absent.
Ma'am, option A.
Yes. Yes, polar molecules are having the permanent dipole moments. Option A is the correct answer. So question number 29. A spherical conductor of radius 10 centimeter has a charge distributed uniformly. What is the magnitude of the electric field at a point 15 centimeter from the center of the sphere? So you have to calculate the magnetic field. A spherical conductor of radius 10 centimeter. So radius is given. Otherwise, you can do it as a homework, students. Or else you can try here. B. Yes. So here the electric flux for a spherical conductor, electric field for a spherical conductor is given by K into Q divided by R square. So K is 9 into 10 raised to 9. Charge value is 3.2 into 10 raised to minus 7. And the distance value is also given 15 centimeters. So 15 into 15, 225 into centimeter is 10 raised to minus 2 square is 10 raised to minus 4. So do the calculation, you will get the answer. Yes, you will get option B, C, students. 1.28 into 10 raised to 5. So if you miss the decimal, your answer will be wrong. Okay. Because you can see all same ide, just powers alli change kottidare. The last question. A point Q lies on the perpendicular bisector of a electrical dipole of dipole moment P. If the distance of Q from the dipole is R, if the distance of Q from the dipole is R, then electric field Q is proportional to. So electric field Q is proportional to anta ಹೇಳ್ತಾ ಇದ್ದಾರೆ. Yes. So if you remember the derivation, you can answer this. Okay, so for the perpendicular bisector that is on the equator and on the axial line, it means, so we have the expression electric field is equal to 1 upon 4 pi epsilon naught Q divided by, okay, so P divided by it is R cube for the
Ma'am,
axial. Option
D.
Yes, D is the correct answer. Yes, option D baratte nodi students. So this completes your first topic, that is electric field and the charge. Okay, so here as electric field is directly proportional to dipole moment and it is inversely proportional to cube of that, you can conclude from this. So E is proportional to P and E is proportional to R raised to minus 3. Option D baratte. Yes, so this completes your first topic, electric field and the charge. So almost ella concept mele questions anna cover ಮಾಡಿದೀವಿ. So theory is already completed. This also we have completed. So next class we are going to start with the electric potential and the capacitor. Okay, so revise the topic. So you can solve few more questions. ಬೇರೆ ಬೇರೆ author books ತಗೊಂಡು ನೀವು ಮತ್ತೆ solve ಮಾಡಿ practice ಆಗತ್ತೆ. We will meet in the next class, students, with the next topic. Thank you, everyone.
Thank you, ma'am. Bye, ma'am.
Okay, bye.